So last episode, I said I'd tell you when I made the engine decision. I made it, and it's not Bevy, it's not Godot, it's both in a way. In episode one, I said the game was going to be built in Rust with the Bevy engine, and in episode two, I said everything might change. And as it turns out, and as I hinted, the engine is one of those things. And the answer wasn't switching to something else; it's figuring out I didn't have to choose. So as some context, for anyone not in game dev, an engine is a tool you build a game in. It handles things like rendering, physics, input, audio, and basically the infrastructure of the game, and you build on top of it. So Bevy is a Rust game engine. Rust is the programming language I have the most experience with, and it's also my favorite. And then Bevy is a code-based engine that uses an architecture called ECS, Entity Component System, which is a way of organizing game logic where everything is made of parts you can mix, match, and swap. And for a shape-shifting game, it's quite powerful because switching forms means you simply switch the parts on your character and the entire combat system changes. And it's pretty simple because you're not checking bool. It's a lot simpler. As a note, there is no visual editor for Bevy. Godot, however, is a general purpose game engine with its own scripting language called gdext. And it has a full visual editor, animation tools, and tile map tools, which is everything you'd expect from a game engine with a decade of shipped games behind it. It's also the most popular open source game engine when it comes to using something like Unreal or Unity. So I guess I'm covering it. That's my bad. Let me scoot the other way. So what Bevy gives me is Rust end-to-end, which, as I mentioned before, is my strongest language. And then it gives ECS composition, which means shapeshifting just swapping parts. It gives me type safety, because with Rust, the compiler will catch my bugs. And then it gives me a RON data flow where I have a open source project that will validate all RON files for me on compile, and then and out during runtime. Well, not during run, on load, and then an architecture, a bunch of architecture docs that can move to code pretty simply with zero translation. However, it does cost me. There is no visual editor. Everything's built in code. So if I want to place an enemy in a room, I have to write coordinates. And then adjusting animations and stuff is I have to change numbers, recompile it, run the game, check it, adjust, recompiling again. And that can get expensive time-wise. There's no tile map tools built in, so everything's handcrafted, and that's a bit of a pain. And while there's third-party plugins, Bevy is pure pre 1.0, and so whenever it updates, the plugins break until they update to match the new version of Bevy. And I'd be depending on community crates that may or may not keep up. Compile times, Rust is not very fast to compile. Multiple second rebuilds for every change. And when you're tuning a pairing window, which is set to about 133 milliseconds, every second in the compile loop is a second you're not feeling the game. And then there's stuff like there's no animation timeline, so combat tuning takes a bit. There's very few shipped games using Bevy, and so there's a lot more there's more unknowns in the story of Bevy and game development. Now for Godot. So Godot has a full editor and inspector. So it has an animation timeline and a tile map editor. The visual tools that Bevy doesn't have, so I can see the game world, place things, and adjust them visually and run the game in 2 seconds, which compared to Rust is literally the snap of the finger. The 2-second launch time, as mentioned earlier, is really nice, which for very focused game that will need a lot of tuning, potentially hundreds of hours for the feel, near instant iteration isn't a luxury thing for me. It's a fundamental thing I need to have. And then it has one-click export to multiple platforms. So I don't have to have a custom build pipeline for each platform I want to ship to. And then it has hundreds of shipped games and so it has a very proven track record. So its cost, so gdscript is a dynamically typed language, which means uh, the safety I have with Rust disappears and typos become runtime errors. If I rename a variable, I have to hope I catch every reference. And for a combat system with layered interacting states, action locks, and vulnerability frames, stagger, hit stop, animation commitment, type safety catches integration bugs. Dynamic typing only surfaces when a specific combination of states happens during play. And then there's no native ECS. So Godot uses a hierarchical node tree, objects with inheritance, which works fine for many games, but it's a fundamentally different way of thinking about game logic than what my architecture docs describe. And the component composition model that makes shapeshifting elegant in ECS becomes inheritance hierarchies in Godot. The next thing is I'd lose my RON data pipeline. RON, which stands for Rusty Object Notation, I have a validator for it that I've shipped as an open source project. And it would become completely useless if I stayed with Godot, if I only used it. And the entire data-driven architecture idea behind my game is that it keeps all the gameplay values in external files, all validated at load time, would need to be rebuilt in a different format. And then I'd also lose access to Rust, which is my strongest language and my favorite. So the core tension is that both systems solve half the problem and both ignore the other half. And so I spent days going back and forth, and then I realized I was asking the wrong question, and the question isn't Bevy or Rust. The question is, can I use both? And my answer ended up being yes. And there is a tool that makes it work. So, third option, Rust and Godot. So gdext is a Rust binding for Godot. It lets you write Rust code that runs inside Godot's runtime. So I get Godot's editor, tools, animation system, and export pipeline. But my game logic is written in Rust instead of gdscript. And this isn't something that's theoretical. People ship production code with it, and it's actively maintained. So I get to keep Rust, I keep type safety, I keep my RON pipeline and my schema validator, and I gain everything Godot offers. But I went one step further, because just writing Rust in Godot doesn't preserve the ECS architecture. Godot still uses nodes and scenes, not entities and components. So my docs would need heavy translation. So instead, what I'm doing is I'm running a lightweight Rust ECS inside of Godot, a crate called Hex or HECS, a small, stable, separate from Bevy crate, and it handles all the game logic. Components, systems, queries, events, all the patterns from my architecture docs, while Godot handles the rendering, physics, input, and the editor. So the ECS crate is the brain, while Godot is the body, and then I have a bridge connecting them. So the bridge. So everything on the left is what you see or hear, what you actually interact with visually and with all your senses. So that's the scenes, the sprites, the physics engine, the animation player, the collision shapes, tile maps, audio, camera, the HUD. And then everything on the right is what happens: health calculations, mana calculations, damage math, enemy AI, parry logic, form switching, combat state, save data. All game logic runs in Rust. The bridge is a connector point. and it's the single connection point. It's called a mediator. So it collects input from Godot, feeds it to ECS, then takes the ECS decisions and sends them back as commands for Godot to execute. So Godot doesn't make decisions and ECS isn't drawing anything, and both sides are doing what they're good at. And what transfers from the existing architecture is about 85 to 90% of the architecture docs that I've written with the help of AI over the last about 3 weeks. And 3 weeks doesn't sound like a lot, but this is over 120 docs. So it's a lot of work, and it all transfers over without needing to redo a lot of it. So the component designs, the system boundaries, an event pipeline, data schemas, and the modding architecture, all of it is built for ECS, not Bevy specific patterns. And then the bit that doesn't transfer is Bevy specific. And so that's the part that a lot of that I'd have to build from scratch anyways. So it works out, and all that design work wasn't wasted because of how much transfers. Because it was a lot of it was engine agnostic, focusing mainly on the implement the kind of engine, so ECS over inheritance, and not specific to the engine that I was trying to use initially. Okay, so I'm going to walk through how it works using a single attack. So, player attacks a boar. Simple. Here's what happens under the hood. Player presses attack. So you press the attack button, Godot detects the button press, and the bridge collector reads that input and translates attack pressed, forward direction grounded, and that message goes into the ECS. And then the combat logic takes place with the ECS combat system taking over. And it does things like it checks, can the player act right now? Are they locked in another animation? Are they staggered? And if they're free, the player's locked into an animation, attack animation. And the player is now committed. They can't cancel, can't dodge, can't parry. Committed at combat. It's a decision, not just a button press. And then we go to the hitbox. After startup frames, the windup of the swing, the ECS will create a hitbox. The bridge tells Godot to spawn a collision shape at the right position. Godot physics engine detects the overlap between the hitbox and the boar's hitbox. And that collection signal comes back as a damage event through the bridge. And then the damage math is run. The ECS runs the math. Oh, the boar had 30 HP. It's taken 4 damage. Now it has 26. And the player generates 6 mana from that hit, because mana comes from combats, not pickups, for the most part. And then the ECS decides, does this hit deserve? This hit deserves a 50-second, millisecond hit stop, a camera shake, knockback, hit sparks, a sound hit, a hit reaction animation, and then all those decisions become commands. 8 commands from a single attack, and the bridge sends them to Godot in priority order. Time control first, then state changes, then visual effects, then UI updates. And then we get to the execution, where Godot executes every command, where it plays the animation, it shakes the camera, spawns the particles, updates the health bar, updates the mana bar. Godot doesn't know it was a board. It doesn't know that the hit dealt 4 damage. It doesn't know why the camera is shaking. It just does what the command says, and the puppets move. And why this matters for my game is every number in that sequence, the 4 damage, 6 mana, 50-second millisecond hit stop, the knockback force, lives in an external data file, a RON file. Change the number, the behavior changes without recompiling and without editing the animation. And a modder can do the same. So they can change the parry window from 133 milliseconds to 200, make the boar hit harder, give the player more mana per hit. It's all just data. And then the game logic, the combat system, the damage math, the mana generation is pure Rust. I can write tests for it. Automated tests that run without Godot even being open. If the player parries during frames 1 through 8, they should take 0 damage and gain 15 mana. That's a unit test. No manual play testing is required for the math. Now, the parry scenario. It works basically the same, only it's the board attacking, but the player parries. Collisions detected. ECS checks parry state. It's the elapsed time, so let's say, is only 0.02 seconds, which is within the 0.133 second full parry window. Result is full parry. Take 0 damage. 15 mana. Board gets staggered for 0.9 seconds. And there's a longer hit stop of a 0.1 seconds because a parry is a big important moment in the human way of doing combat. And the player can immediately attack the staggered board. And the difference between a full parry and a miss parry is a few milliseconds of timing. The ECS tracks that in delta time, real seconds, not frame counts. So the game will run the same whether you're at 60 FPS, 144 FPS, or 30 FPS. Now, why this? Why am I actually doing this? And I'm going to be honest. I have 4 stalled game projects. 4. And all of them started the same way. I got excited, jumped into code, and stalled when the work stopped being interesting, or I just didn't know where to go next because I didn't know what I wanted to build. And every one of those projects died at the same point. The gap between I have an idea and I have a character on the screen. Admittedly, some of them did have a character on the screen, just not much of an idea. And the architecture part, the part where you're building infrastructure, not gameplay, that part looks nothing like what is happening with this project. So when I picked this approach, I didn't choose the fastest approach. I was picking the path that is most likely to result in a shipped game for me. I'm not saying this will work for everyone. In fact, a lot of indie devs actually start building a game they get an idea and they just start building, and it works wonderfully. I'm not one of those people. As I mentioned before, I have tried, I have failed, and I don't want to do so again. If I'm going to build something, I'm going to build it the way that I can build it. And with the way my brain works. So this ECS bridge architecture is the kind of work that I'll show up for daily, because building a clean system, solving hard design problems, and making things compose elegantly keeps me motivated. If I were writing GDScript, the technically faster path, I'd be fighting the language instead of enjoying the work. And when you fight your tools, projects stall. And I don't want that to happen with me again. And I know this sounds like I might be rationalizing, and I may be, but I also know projects that I also know that I have 4 stalled projects, and none of them stalled because the tech stack was too interesting. Now the cost. This approach does have a real cost. The bridge, the mediator alone, that connects ECS to Godot, is infrastructure that someone using pure Godot wouldn't need, and it's estimated to be between 500 to 800 lines of code. And that's a tax that I'm paying for the privilege of using both. And this is also a novel approach. Not a lot of people are running a Rust ECS inside of Godot. So there's less community guidance, fewer tutorials, and a lot more of figure it out yourself. So I'm a second-class citizen in a GDScript first-class ecosystem. Technically, I could also call myself a third-class citizen, because there's still a lot more support for using gdext within to use Rust, just not to use it to be able to use an ECS with Rust. And then, to be honest, like, another cost is the architecture could become the project. So I could spend months building a bridge and never build the game on top of it. And so I've just built my 5th stalled game project with better infrastructure, but it's still stalled. So guidelines that I've set for myself. Um, First rule is a character has to be on screen within 2 to 3 weeks. Not a finished game, not a demo, just a character walking in a room through the bridge with input going through the ECS, commands coming back. And this will be a square block. It will not be an actual like normal character in the final game. And so if I can't hit that milestone, the approach is wrong. And the bridge should take 3 to 5 days to get to the minimum viable level, not 3 to 5 weeks. So, and that's estimated at about 300 lines of code for the core stuff. The collector, tech controller, a dispatcher, and the entity map. And so the bridge will grow alongside game features, not before the features exist. So the architecture will serve the game, and the moment the bridge starts growing faster than the game features, I have to take a step back, reassess. That's the rule. Okay. Yeah. So, yeah. Um, yeah. A lot's changed as well. So as mentioned before, I went from Bevy, and as mentioned in the entire episode, I've gone from Bevy to Godot with Rust using the hex ECS create via gdext. What else has changed from episode 1 is the resource system is no longer, there's no stamina. So instead there's a cooldown. Architectures, there's still 6 layers, 0 through 5, and it's still bottom up, data driven, and testable at every layer. And the layers describe game logic, not engine specifics. Things that are exactly the same is everything that was in the stable box from episode 2. So the mythology, Hecate, or Hecate, the coalition, shapeshifting, parry combat, the tone, the moral complexity. That's all the same. The data-driven architecture, where every gameplay value is in external files, and things aren't modding friendly by design. The run pipeline stays. My validator for it stays, and then type safe Rust is staying. And then also my expansion model, where every release is a complete story. It might not be the full story, but it ends at a good point, and you could technically call it an end. So new things that this debate produced were stuff like the shapeshifting transitions are now vulnerable, where if you shift forms, there's a brief animation from 0.2 seconds to 0.3 seconds, where you can't act and you can take damage with no iframes. You have to find a safe window to shift, and same way you have to find safe windows to heal in Hollow Knight. I am pulling from Hollow Knight Silksong when it comes to healing, and using that same kind of mechanic for shifting. If you shift in mid-air, you hover with gravity and velocity suspended, and you're a visible stationary target. The costs are proportional. You're exposed and predictable, not chaotic. And if you get hit during the shift, it cancels. You stay in your original or current form, and the cooldown doesn't trigger. You didn't actually leave the form. So you can try again immediately with no double punishment, but you still got punished and took damage because you chose the wrong time to shift. And this came out of the engine debate because we were walking through the game features, through the bridge architecture, and then testing how would shapeshifting would mechanically work for the change and the design decision. And so what's next? So the engine decision's been made, which means next step is code, actual code, which is definitely the scary part. And so while yes, I'm transitioning from design and architecture to code and implementation, the design phase isn't over. It never is. But the next time I talk about this game, something should be running, even if it's just that gray blocks character moving across walking in a room. So milestone is character on screen in 2 to 3 weeks. It could be sooner. And it's going to be through the bridge. Input goes in the ECS, commands come back, and Godot executing them. And if that works, the next episode after that is combat. Getting a parry to feel right through the bridge, getting hit stop to freeze the game for exactly 50 seconds, 50 milliseconds, I should say, not 50 seconds. Getting the camera to shake on impact. And so the destination hasn't changed. I just picked the vehicle and it's already set in stone because I have already started implementing.